So today we're gonna go over a really popular topic, more popular in like AMC 10s and like math counts. But I don't think these are seen that much in AMC 8s, but they're still really important to know. Dude, I have do not disturb on. I don't know why I'm getting notifications. Quadratics. Okay, so first we're gonna introduce what quadratics are. And it's okay if you don't know what they already are. They're just really basic. They're basically any expression that has an x squared term in it. Bx plus c. So that's a form of a quadratic. And then one of the most important things you can find from a quadratic is called the roots. Now, roots have a lot of different names that you might hear. You might hear them called like solutions, or like maybe zeros. Just a bunch of different names, like x-intercepts and stuff. But just know they're all the same thing. So what it is basically what values of x such that expression ax squared plus bx plus c is equal to 0. That's the definition of a root. So let's just give an example. Quadratic would be like x squared plus 6x plus 8. And then to find the roots, we would set this thing equal to 0. And then I'll quickly go over how to find roots later. But just to know that -2 would be a root in this case. Because if you plugged in x equals -2, then you would get 4 minus 12 plus 8, which is equal to 0. So that would be like a root for this quadratic. And quadratics always, they always have 2 roots. So the other root would be x equals to -4. And this works because once we plug into the equation, we have 16 minus 24 plus 8 is also equal to 0. Everything makes sense so far, right? Okay, I think everyone said yes, so I'm going to continue. So one way we can find the roots is we have something called a factored form. Let me submit them. Okay, so a factored form is something in the form of like x minus r1 multiplied by x minus r2. And this is the factored form for a monic quadratic, which means the leading coefficient is 1, or a equals to 1. So if we find the factored form, it'll be really easy to find the zeros, since the zeros will be x is equal to r1 and x is equal to r2. Since plugging these two in will obviously give you 0. So the factored form of like the previous quadratic we used, x plus 6, x plus 8, we know that we can write this as x plus 2 multiplied by x plus 4. And we can just confirm this by like expanding it out, doing x squared plus 2x plus 4x plus 8, which is the same thing as this. So we call this the factored form. And something to notice about the factored form is like if we have x minus r1 and x minus r2, if we expand this out, we will get x squared minus r1 plus r2 times x plus r1 times r2. Everyone gets how I get that equation, right? Okay. So basically, the way we can factor a quadratic like this is we want to find two numbers, r1 and r2, that multiply. They multiply to the c value and then they add up to the negative b value. So let's just give an example. If we have something like x squared minus 8x plus 15. The way we would factor this is we want to find two numbers, or the two roots, r1 and r2, such that r1 plus r2 is equal to negative b, or is equal to 8. And then we want to find two more numbers, the same two numbers. Shoot. R1 times R2 is equal to 15. So like we can test out numbers, but like we can see that R1 equals 3 and then R2 equals 5. These two actually satisfy both equations. And then that means that we can write the quadratic as x minus R1 times x minus R2, or just x minus 3 times x minus 5. And then to confirm this, we can expand this if we wanted. We can just get x squared minus 3x minus 5x plus 15 plus 15. And then we would get our original quadratic from here. But in this form, we can easily find the zeros, because the zeros are just x is equal to 3 and x is equal to 5. Because if one of the numbers in the parentheses is 0, then the whole product is 0. Okay, factoring makes sense to everyone so far, right? Okay, sure. I'm gonna take that as a yes. All right. So the next method I'm gonna teach is called completing the square, and this method, is it's probably not like a method that everyone likes, but it's still important to know. It's important to derive like quadratic formula and stuff. So let's say we have completing the square. So first, let's introduce what a perfect square quadratic is. So a perfect square quadratic is something that looks like x squared plus 10x plus 25. And the reason this is a perfect square quadratic is if we factor this, we want to see two numbers, r1 plus r2, that equals to 10, negative 10, and then two numbers that multiply to 25. And clearly we see that r1 and r2 are both equal to negative 5. And since both of the roots are the same, we would call this a perfect square, because we can write it as x plus 5 times x plus 5, or just x plus 5 squared. So this would be a perfect square. If we look at the general form of a perfect square quadratic, it will be in the form of x plus a squared, where a is any number. So if we expand this out, we would get x squared plus ax plus ax plus a squared, which is just equal to x squared plus 2ax plus a squared. So that's a form of any perfect square quadratic. So like, why are these even important in the first place? Perfect square quadratic lets you easily take like a square root of a side, and you can cancel out the x squared. The reason quadratics are hard to solve is The x squared term makes stuff like complicated to handle. So using the completing the squared method, we basically complete complete the perfect square quadratic on one side. So if we have, let's just use a previous example of x squared plus 6x plus 8. So the first step we're always going to do is we're going to move all the constants to one side. And the constants are all the numbers. That's a constant. All the numbers without an x attached to them. So we want to move them to this side. So we basically have x squared plus 6x is equal to negative 8. The next thing we want to do is we want to make this left-hand side a perfect square, or something in the form of x squared plus 2ax plus a squared. And to find the number, we have to add to both sides. We simply take this middle term right here. We divide it by 2. So we divide this term by 2, and then we square it to get our constant term. So 6 over 2 equal to 3, and then 3 squared is equal to 9. So to form our perfect square quadratic, we would want to add 9 to both sides. So we would get something like x squared plus 6x plus 9 is equal to 1. And now we have a perfect square. On our left-hand side. So that means we can rewrite it as x plus 3 parentheses squared equals to 1. And now this equation becomes easier to solve since we can just simply take the square root of both sides and we can get rid of this squared. So we can just get x plus 3 is equal to 1. But the thing we have to keep note of is that the square root of 1 is not just 1. It's equal to 1 and negative 1. Since both of these numbers squared will give you 1. So we can write this as plus minus 1. So it's either plus 1 or minus 1. Solving this, we can get x is equal to negative 3 plus or minus 1. So x is equal to negative 3 plus 1, which is negative 2, or negative 3 minus 1, which is negative 4. So these are the two solutions that you get from completing the square. And as as verification, we can see that it's the same as all the methods we did previously. And I think that's it for completing the square. Does that make sense to everyone? Okay, I'm gonna take that as a yes. So I'll just move on. I'll probably move. This is the method that like everyone uses for everything because it just works every time. It's just a quadratic formula. And this formula is kind of long. So like if the previous two methods work better, then you should probably use that. But like if the numbers are like really big or something. Oh, Andrew, the first method is factoring. Yeah. Quadratic formula works always, but the computation might get heavy. And it's kind of, at the beginning, it's kind of hard to memorize the whole thing. So the formula basically states that the roots of a quadratic, that's ax squared plus bx plus c, the roots are going to be expressed as negative b plus or minus the square root of b squared minus 4ac over 2a. So this formula might look like really scary at first, but once you use it a couple times, it'll get better. So right now, I'll show you a quick way to derive it. You guys don't have to understand like every step I do, but it's just good to get like introduced with these methods. So first, we have the quadratic, and we set it equal to 0. We don't like this a at the front. We don't like this a. So what we want to do is we want to divide the whole entire thing by a. So we want to get x squared plus b over ax plus c over a is equal to 0. And then now we want to complete the square to solve this quadratic. So we want to move all the constants to one side. So we get x squared plus b over ax is equal to negative c over a. And then to complete the square, we're going to divide the middle term by 2. We're going to divide b over a over 2 to get b over 2a. And then we want to square this number, which is equal to b squared over 4a squared. So we can get x squared plus b over a x plus b squared over 4a is equal to b squared over 4a minus c over a. And now, using completing the square, we have a perfect square on our left side now. So we can write it as x plus b over 2a squared is equal to b squared minus 4ac over 4a. Oh, there should be a squared here, my bad. Okay. And then next, we simply take the square root of both sides. So we get x plus b over 2a is equal to, remember the plus or minus square root of b squared minus 4ac over 4a squared. And then finally, we just subtract it over to get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. So that's our original formula. Now you can type any questions you have in the chat if you want, but it's okay if you don't understand everything of this deriving. So I'll just show like one example of this in action. Let's just use our original quadratic again. Actually, I'll just use a different one, so it has a different leading coefficient. 2x squared plus 3x, sure, minus 1. Okay, that's fine. And then we have a is equal to 2, b is equal to 3, and c is equal to negative 1. And if we use the formula, we have the roots is equal to negative b plus or minus the square root b squared minus 4ac over 2a. So we can just plug in all these numbers, and we get negative 3 plus or minus the square root of 9 plus 8 over 4. So it's equal to negative 3 plus or minus the square root of 17 over 4. And as you can see, the quadratic formula works really well for equations like this, because you can't really factor this question. And completing the square is kind of a pain to do every time. So applying the quadratic formula is just a quick way to solve this. Why do I keep getting so many notifications? All right, so like everything we've learned up to this point is something that you'll probably learn in school, like in the future, maybe like grade 7 or 8. Yeah, I don't know. I get so many emails. Like I have do not disturb on, I think. That's weird. Whatever. So the next two topics are actually you'll probably learn one of these topics in school as well. But this topic, Vieta's formulas, you probably won't learn this at school. At least I haven't. So what it states is for if you have a quadratic ax squared plus bx plus c, and it has roots r1 and r2. It basically states that r1 plus r2 is going to be negative b over a, and r1 times r2 is going to be c over a. And this proof is basically the same thing as factoring. What we do is we don't want this a coefficient here, so we can just divide it out and get x squared plus b over a x plus c over a. However, if we factor this into its two roots, into x minus r1 and x minus r2, we can find that minus r1 plus r2 x plus r1 times r2. If we match up the coefficients, we'll see that negative r1 plus r2 is equal to b over a, and we can see that r1 times r2 is equal to c over a. That's basically how you derive it. And then an application is like, if we apply it to our original equation of x squared plus 6x plus 8, what it basically tells us is that r1 plus r2, the sum of the two roots, is equal to negative b over a, which is negative 6. And it tells us the product of the roots is r1 times r2, which is equal to c over a, which is equal to 8. And we already know that r1 and r2 equals these values, and this can be easily verified to work. Vieta is more useful if you can't find the roots of like a quadratic, if it's more complex or something. And then the last thing I'm going to go over before we head on to some questions is optimization and like the vertex. So basically, if a question ever says find the max or the minimum of a function, let's call it if a question ever asks you that, then it's always at x is equal to negative b over 2a. And a way to show this is basically, and this is also called the vertex, by the way. The way to prove this is like we can rewrite the quadratic into a completing the square form. Well, it's called vertex form, actually. We complete the square of these two terms. So we can make this into x squared plus b over a x plus c over a. And then we complete the square I've already done this multiple times, so I'll just skip most of the steps. Wait, there should not be an x. Okay, sorry about that. Should be this squared minus b squared over 4a squared plus c over a. And then we notice that when we vary our x value, these constant terms don't change. Because like whatever x we plug into our original equation, these won't change. The only thing that's going to change is what's in this section. And we notice that since it's squared, it's always going to be non-negative. So when we want the minimum or maximum, we want this value to be 0. We want like x plus b over 2a to be 0. Or we can just have x is equal to negative b over 2a. That's always where the maximum or the minimum occurs. Okay, so that's basically it for the instructive part. And if no one has any questions, I'm going to move on to the problem sets. Okay, so this is problem 1. It's really basic, and it appeared on the AMC 10 this year. So ask for what is the sum of all real x that satisfy this equation. And if you don't know what these two bars are, it just means absolute value. So like, it basically makes it positive. Yeah. So if it's negative, it just gives you the positive value. So what this is saying is that it can x squared. Actually, I'll give you guys a chance to solve it first. I'll give you guys like a minute or two to try and attempt this question.
Oh, I can do this. This is easy. One x squared plus negative 2 plus
Okay, do you guys need more time? Oh, I already seen one answer in the chat. Wait, put something in the chat if you need more time. If I don't see anything, I'm going to start soon. Okay, I don't see anything, so I'm just going to keep going then. So what this is saying is we can either have x squared minus 12x plus 34 Oh, you took this test? That's good, Aiden. And we have the second case, which is x squared minus 12x plus 34 is equal to negative 2. So let's just go with the first case first. So if we clear this side to make it look like a normal quadratic. We move the 2 to this side. We can easily solve this by factoring. We don't want to use a quadratic formula because like these are time tests and we don't want to take too long on them. So we just want to find 2 numbers. Obviously, you wouldn't write all of this out on an actual test, but for the sake of teaching, I'll write this all out. We want to find 2 numbers that add up to 12 and 2 numbers that multiply to 32. And yeah, David said it in the chat. That's going to be 4 and 8. So this thing can be factored as x minus 4 and x minus 8. So basically, its roots are going to be 4 and 8. So we've already found 2 numbers that satisfy our original equation. And now we have to go to our second case, which is just x squared minus 12x. So we add the 2 this time. So we get plus 36 is equal to 0. And you can recognize this as a perfect square, or you can just do the same process again. But we'll just get R1 equal to R2 is equal to 6. So this is just equal to x minus 6 squared. So the only root to this equation is 6, since it's counted 2 times. And then now the question asks for the sum of all the real x's. So we can just do 4 plus 6 plus 8 is equal to 18. And yeah, I saw this answer in the chat, which is good. Does anyone have any questions on how this was solved? All right, everyone looks good, so I'll move on to the next one. I wrote this. Okay, I wrote this one. Never mind. So Farmer John wants to plant a garden. I'll let you guys read it because talking is tiring. Okay, so I'll draw. The first thing you want to do is draw a diagram for these questions. So let's say this is the wall of his house. It says he wants to build 3 sides to enclose a garden. So it's going to look something like this. And it's told that he has 100 yards of fence. No, his house length. Oh no, his house doesn't matter because it's gonna like extend infinitely. Well, we can assume that. Normally this would be a square, but since one of the sides is already taken, it's actually not going to be a square.
Mm.
Oh, Andrew, farms are pretty big. Farms are pretty big. Okay, so first thing is let's just let one of the lengths be x. And since we know that all 3 sides add up to 100, we know the last length is going to be 100 minus 2x. So what we want to do is we want to maximize this area right here, or the area of the rectangle. Jennifer, no, it doesn't. It can be like x can be anything. We just want to maximize the area inside the garden. So I'll let you guys try this one, but since it wants a maximum area, we want to use the optimization tricks we've learned to find the maximum area. I'll give you guys like 1 or 2 minutes of it. Okay, is everyone ready to go over this one? Okay, I think that's enough time, so I'll start going over the solution to this question. Why do I keep on getting notifications? Dude, iPads are whack. All right. So we want to find the maximum value of this area. But the way we can express the area is as 100 minus 2x, the base times width times length, basically. So that times x equals the area. And then if we expand this, we will get negative 2x squared plus 100x. And since we want to maximize the area, we want to maximize this value. But remember, I told you that when you want to maximize the quadratic, this is a quadratic. It looks different because it doesn't have a constant term, but we can imagine it has a plus 0 at the end. So the maximum is always at x is equal to negative b over 2a, which is equal to negative 100 over 4, over negative 4, which is just 25. Right? So now we just find the area when it's at 25, when x is equal to 25. We just plug it into 100 minus 2x times x, which is equal to 100 minus 50 times 25, which is equal to 125, 0. That's going to be the maximum area. So like, since this value is the maximum, it's going to be bigger than like everything you guys put in chat. So yeah, usually like the shape is going to be a square, but since one of the sides is already taken, we can't assume it's a square anymore. Does everyone understand like the methodology behind this? All right, so that basically covers most of the optimization questions. And then now we're going to go over to some Vietta's tricks. Actually, this is kind of messy. I'm going to rewrite it because it looks bad. So given we have a quadratic, let's just say it's x squared plus 4x plus 20. And then we say that it has two roots, which is r1 and r2. So these are the two roots of the equation. So the question is going to ask you to find r1 squared plus r2 squared. And to also find 1 over r1 plus 1 over r2. Don't look at that. Oh my. Okay. So I'll let you guys try these two to find these two values. But a hint is to use Vietta's. We can use Vietta's to find the values of r1 plus r2 and r1 times r2. we don't want to find the values themselves because that's going to be messy. And like this equation doesn't even have real roots. So that's going to be really confusing. Why do I keep getting notifications? All right, I'll let you guys try and find these two values. Okay, I'll just go over it like right now because whatever. So the key to both questions is to express both of these expressions in terms of these two basic expressions. Because we know both of these values from Vieta's. But we want to find this value in the end. So if we notice that if we square R1 plus R2, we're going to get R1 squared plus R2 squared plus 2R1 R2. So look, this is the thing we want to find. But then we have like this leftover stuff, which is annoying because we don't want to find that in our sum. But we also know this value. So we can just get this is equal to, well, I'll just clear the bottom out real quick. This is equal to R1 plus R2 squared minus 2R1 R2. And let's find these values first. Let me just clear some space out. We have R1 plus R2 is equal to negative B over A, which is also equal to negative 4. And then R1 times R2 is just equal to C over A, which is equal to 20. So we want to find this value. So this is basically negative 4 squared minus 40, which is equal to 16 minus 40, or is equal to negative 24. And yeah, you might notice that, look, how can the sum of two different squares be a negative number? That just seems really strange. But you have to notice that the roots of this quadratic aren't necessarily real. They're going to have like imaginary roots, which is like more complex, pun intended, but like you won't really need to know about them. You just need to know that they exist. So that's why the sum of two squares might be negative. And then finally, we're going to find 1 over R1 plus 1 over R2. Wait, this is so common in like a lot of different competitions. And you'll see later in the next question. Notice that if we have a common denominator, we just like make common denominators. We can write this as R2 over R1 times R2 plus R1 over R1 times R2, which is just equal to R1 plus R2 over R1 times R2. And look at that. We have both of our values that we know. So then we just do negative 4 over 20. And we get negative 1 over 5. So that's going to be the value of our 1 over R1 plus 1 over R2. So these actually show up a lot in competition. So you just got to memorize like clever ways to write these expressions. And finally, this is going to be our last question, and it's going to use Vieta's again. So what is the sum of reciprocals of the roots of this equation? By the way, a reciprocal of x is just 1 over x. And at first glance, this equation might not look like a quadratic, but like try and manipulate it so it becomes a quadratic. And I'll give you guys a few minutes to try this one as well. Okay, does no one needs more time, right? I'll go over this question. All right, I'll just go over it right now then. So the key to this question is we want to transform this. We want to transform 2003 over 2004 x plus 1 plus 1 over x into a quadratic. So the way we do this is we just multiply the equation by x, like the entire equation by x. And there you go. We have a quadratic. So again, let the roots be r1 and r2 of this quadratic. So the question asks us to find 1 over r1 plus 1 over r2. But from the previous examples, we already know this thing is equal to r1 plus r2 over r1, r2. And we can use Vietas here to find both the values. R1 plus R2 is simply equal to negative B over A, which is equal to negative 2004 over 2003. And then R1 times R2 is going to be C over A, which is just positive 2004 over 2003. And then just finding R1 plus R2 over R1, R2, we got this is equal to negative 2004 over 2003 over positive 2004 over 2003. This is just negative 1. So that's going to be our answer. It's pretty simple once you see these a few times. This was actually a pretty late question in AMC 10. So do you guys have any questions on this? Okay, so if not, I'll go over one final important thing to know about quadratics, which is the graph of a quadratic. And you guys want to know like the basic shape of what a quadratic looks like. So if we want to graph something like ax squared plus bx plus c, we have The y-intercept is, well, the y-intercept isn't really important for like quadratics. You know how like lines of slope-intercept form for graphing? The graphing form of like these is more, it's called like vertex form or something like that. And what we do is we basically write it as a, okay, actually, I'll just go over the shapes first. The shape of a quadratic looks like a parabola. Yeah, it's a parabola. So we call the vertex like the bottom or the top, depending on if A is negative or positive. It can look like either of these. But like, remember when we were trying to find, oh yeah, arrows, whatever. But remember when we were trying to find maximums or minimums? We always want to find the vertex. Because that's going to be like the maximum or the minimum of the quadratic. Another thing to note is like, whenever it crosses the x-axis, is when the function is equal to 0. So these are the two roots. But if we have a parabola like this one, like the top one right here, notice how like it never intersects the x-axis. So you might think it has 0 roots. But like that's not true because it has like imaginary roots, as we've seen. But you might learn more about that later. These points, these are also called like x-intercepts, which are the same thing as zeros, which is why there's so many names for them. Oh, if you're asking with like if graphing these are necessary, like a lot of these questions might appear in competitions actually. You guys should like familiarize of what like a parabola looks like and most of its features and stuff. Oh wait, are you guys talking about something in chat or the graphs? Okay, whatever. If you guys don't think the graphing part is necessary, we'll put like more questions in the problem set this week. We have a problem set every week and we encourage you guys to try it out and stuff. Like the problem sets are always going to be like challenge questions and stuff. That's pretty much it for like this week's lesson. So if you guys have any questions, you guys can put them in the chat. And if not, I think you guys can go if you guys want. Good night, guys. Stay safe.
Good night. Thank you. You all stay safe too. Bye. And don't be bored at home. There's plenty of things to do if you look.